So in today's video, we are going to learn how to convert a standard form of a quadratic equation into the vertex form. Okay, so I start out with this quadratic function in standard form. For example, x squared plus 16x minus 12. So from a standard form, remember, we can easily get the y-intercept. We know it's negative 12. And we know that it's going to open upward because a is positive. Okay, but we don't really know where the vertex is just from looking at this. So we convert it into vertex form. So here's what we're going to do. The first thing you're going to do is go ahead and set it equal to 0. Okay, so we set it equal to 0, and just like before when you completed the square, the next step is that you're going to then move the 12. So you still need variables on one side, and you need the numbers on the other. Okay, the next step is the same also. You're going to divide the b term by 2, so negative 16 divided by 2, and we get 8. Positive 16 divided by 2, and we get 8 squared is 64. So just like before, I add that to both sides. So some of you are forgetting to add it to the other side. Don't forget, it gets added to both sides. Okay, the next step is the same, so I'm going to add those together, and I get 76. On this side, I turn it into a perfect square trinomial. Okay, now, remember, however, we are not actually solving this. So we're not solving to try to get zeros. What we are doing is turning it into vertex form. So the only step that's really different is the last step. So the last step is that you then move this back on the same side as here. So I now subtract the 76, so I put it all on one side, and I have x plus 8 squared minus 76. And then I just put it back in put the y back there, or the f of x. Okay, so now I know that the vertex is at negative 8, negative 76. So remember, it's always the opposite of this and the same of this. So opposite of h and the same as k. Alright, so let's try that again. Okay, so if you think this is pretty easy, you might want to fast forward to the next example, because the next example will have them with a lead coefficient, and you need to make sure that you do know how to do that. Okay, so like I said, first we're going to set it equal to 0. Okay, move the 145. Okay, then I'm going to go ahead and complete the square. So 24 divided by 2 is 12, squared is 144. Always remember that it needs to be added to both sides. I can't stress how important it is to add it to both sides. Then I turn this into its perfect square trinomial. I add this together. Okay, lastly, I put it back onto one side. So when I put it back onto one side, so I subtracted the 1 to put it back on the same side, and then I just put my f of x back out here. Okay, so remember the vertex is at h. Okay, so it's the opposite of h, so negative 12, and then k. So I now know, if I were to graph this, that the vertex is at negative 12, 1. From the standard form, I can tell that the y-intercept is at 145, and I now know that the vertex is at negative 12, negative 1. Alright, let's try this again. So, we know that in order to complete the square, I must have a lead coefficient that is 1. Okay, so what I'm going to do here, set it equal to 0. Okay, I'm going to move the 7. Okay, so after I've moved that, that's when I'm going to factor out the lead coefficient. So don't try to factor it out before. You're going to factor it out at this point. So this is the point where you're going to factor it out. So I'm going to take out a 3. Okay, now, remember, I'm not solving, so I'm not actually going to get rid of this. I'm not going to divide both sides by 3 because I'm not solving. All I'm doing is changing the form of it. Okay, so I'm going to go ahead and complete the square. So negative 6 divided by 2 is negative 3 squared, so I would add a 9 here. So here's where it gets a little tricky. So I just added a 9 here. But it's not like I just added a 9. I put a 9 in here, but there's a 3 out here. So what I just actually added was 3 times 9, because if I distribute this, it's 3x squared minus 18x plus 27. So on this side, I just added 27. So I need to add 27 over here. Okay, so now I can turn this into the perfect square trinomial factor. And then over here I add this and I get 20. Okay, and my last step is to put it on the same side. So I'm going to have 3x minus 3 squared minus 20, and I just put the f of x. And then you might be wondering, but what about that 3? What happens with the 3? Well, the 3 becomes the a value. Okay, and so we'll talk more about that. The a, that just means that it's a vertical stretch, so it's going up at a faster rate. So that does not change the vertex. I factor that out, and that's a positive a value that stretches it. So my vertex here is still hk, so it's the opposite of h, so it's 3, and then my k value is negative 20. So I know that my vertex is actually at 3, negative 20, and this is going to be a parabola that is going upward in a positive direction, and this 3 just gives me a vertical stretch. Alright, so for those of you who need one more example, I'm going to do one more example. Feel free to just stop there if you get it and you're ready to move on. Okay, so I'm going to set it equal to 0. Okay, I'm going to move the constant to the other side. Alright, I'm going to complete the square. No, first I'm going to factor out the 5. So before I complete the square, I need to factor out the 5 here. Okay, so now that I did that, now I'm going to complete the square. So negative 10 divided by 2 and negative 5 squared. So I'm going to add 25. Now be careful, resist the urge to add 25 to the other side. I'm actually adding 5 times 125. So again, this is 5x squared minus 50x plus 125. So it's 125 that I added here, 5 times 125. So I must also add that over here. Okay, so now I'm going to factor this. And I'm going to add those together. Okay, and the last step is that I'm going to then put this on one side. I'm going to put it on one side. So it was negative 3, I add 3, and then just put it back into function format. Okay, so again, the 5 just tells me that it's a positive and it's a stretch of 5, but my vertex is still hk, so it's the opposite of the h term, and then the k term. So I have a vertex of 5, 3. I can tell from up here that I actually have a y-intercept of 128.